In this video, we will look at the subbase and base course of a flexible pavement road, which is the most common type of road used in New Zealand. In most roads, the carriageway is made up of several layers of granular materials topped with a bitumen surface. Together, the granular layers and the surfacing form the pavement. The bottom granular layer is called the sub-base course, or more usually just subbase. The subbase has a mix of sand and gravel with a maximum stone size of 65 millimeters. This aggregate is often called gap 65, which stands for general or passing a 65 millimeter sieve. The top granular layer is called the base course. It is also a mix of sand and gravel, but the maximum stone size is 40 millimeters, which is called a gap 40, or general or passing a 40 millimeter sieve. Together, the subbase and base course form the structure which resists the traffic loads and disperses them, so the loadings are reduced to a level that the subgrade can support without failing. Note that the base course has a smaller maximum stone size than the subbase. This allows the base course to be compacted into a stronger layer that resists both the vertical loads from traffic loadings and the horizontal loads imposed by vehicles turning, braking, and accelerating. Subbase is less expensive though than base course, so the road costs less if you use the subbase for as much of the pavement layer as you can. This photo shows a subbase being constructed. Note the pegs on each side of the road at 20-meter intervals to guide the workers on the location and level of the road. The truck in the background delivered the aggregate, while the roller compacted it. Out of picture is a grader which shaped the layer. Granular layers that make up the subbase and base course are made of aggregate. An aggregate is basically a mix of sand and gravel. The mix of different sized particles is called the grading of the aggregate. The grading needs to fall within certain ranges to allow it to lock together to form a suitably strong layer. For example, a base course needs to have about 5 to 15% fine sand, 10 to 15% coarse sand, 25 to 35% fine and medium gravel, and 45 to 55% coarse gravel, to provide a granular layer that is strong enough to withstand the road loadings when compacted. This mix maximizes the amount of coarse particles in the aggregate with enough finer particles to fill the voids in between the coarse particles. Compaction of the aggregate pushes, kneads, and vibrates the sand and gravel particles into a tightly packed layer. The coarse particles form the primary load-bearing skeleton, which transmits and disperses the road load via the contact points between the particles. Finer particles in the voids between the coarse particles prevent them from moving under load and also distribute the load. In between these finer particles are even finer particles, which again support the coarser particles and distribute the load, and so on. Basically, the coarse particles carry most of the load, while the finer particles hold them in place. If there were no fine particles, then the coarse particles would move under load and the road would settle. Additionally, the particles would be plucked out of the aggregate layer by road loadings, especially the lateral forces involved in turning, braking, and acceleration. If there was too much fine material, then the coarse particles are less likely to be in contact with each other, so preventing them transmitting and distributing the road loads. The loads would be transferred to the fine particles, which would move, resulting in the settlement of the road surface. The mix of particles required to produce the required grading does not happen naturally. Base course and subbase aggregates need to be produced. This is done at a quarry where the rock is quarried, crushed, and mixed to form the aggregates with the required grading that can produce an aggregate layer that has the required strength.